Okay, so we are going to look at an outcome of Newton's second law. So what happens when the sum of the forces, the net force, is equal to 0? This is what we call a state of equilibrium. When the net force, one state of equilibrium, when the net force is equal to 0. Well, what does that mean? Well, net forces cause changes in motion. So if the net force is 0, then there's no change in motion. This implies that the acceleration is equal to 0, which tells us that there is no change in the object's motion. So how does that look? Well, if an object is stationary, I have no idea what I'm writing. Objectationary. If an object is stationary, that means it's not moving as time goes on. If an object is stationary, it's not moving. It means the acceleration is 0. If there's no acceleration, there's no change in motion. So it's just going to stay not moving or stationary. Well, that's pretty straightforward. Until what? What can I do to get that object to move? Well, I have to apply a net force. A net force. Not just one force, but a force that, maybe just one force, but not necessarily just another force, but a net force. And that net force has to be non-zero. I have to have a value for my net force. Acts on it. Until that point, the object has 0 net force, which means the acceleration is 0. There's no change in motion. It seems pretty straightforward, but I just want to make this very clear. Now, a stationary object isn't the only thing that doesn't change its motion. If an object is moving at a constant rate, constant rate tells me there's no acceleration, there's no change. Well, if there's no change, it will continue at that constant rate. Well, what if I want it to change? What if I want it to change its motion? Well, the only way I can do that is if I apply a non-zero net force. So it'll stay at that constant rate until a non-zero net force acts on it. And at that point, it'll change its motion. But until that point, it's just going to keep moving. So if I'm moving at a constant force across the board, am I experiencing forces? Absolutely. My feet are interacting with the ground. Gravity's interacting with me. The ground are interacting with me. I'm experiencing forces. But if I'm moving at a constant rate, my net force is equal to 0. And until something changes about that net force, I will continue at that constant rate. So the only way I can get an object to change its motion, whether it's stationary or whether it's already moving, is to cause a non-zero net force to act on it. That's all there is to Newton's first law, Newton's first law. This is Newton's first law. It really comes out of that second law, that relationship between forces and changes in motion. Good job.